Next definition is skew Hermitian matrix. Skew Hermitian matrix. Skew Hermitian matrix. The square matrix. The square matrix capital A is said to be skew Hermitian matrix. If a power theta is equal to minus a, so we have some similarity. If a power t equal to a is symmetric, no? So observe the name of the matrices. If a power t equal to minus a, then a is skew symmetric. Just we are observing the name of the matrices. Now next one is a power theta equal to a. A is Hermitian matrix. A is Hermitian matrix. Now last one, a power theta equal to minus a, then A is skew Hermitian matrix. Skew Hermitian matrix. Skew Hermitian matrix. So already, so these two are similar. And these two are similar. So don't confuse a power t. What is meant by t? Transpose. A power transpose equal to this one. So these two are similar and these two are similar. Now we have a one similarity. Note. If A is symmetric, if A is symmetric, square matrix, then A is square matrix, then number 1, A is equal to every square, of course, you may write it is symmetric. Hermitian matrix, it is skew Hermitian. Means what? That every matrix, square matrix can be written as sum of Hermitian and skew Hermitian matrix. So like we have one more statement. Sum of symmetric and skew symmetric is also there. So one more issue, it is A is equal to A plus A transpose by 2, A minus A transpose. It is symmetric, no? And it is skew symmetric. Skew symmetric. So next one is periodic matrix. Next definition is periodic matrix. We are listening the types of matrices, special types of matrices. These are useful for entrance exams only, like MSET and JEE Main and IIT. So don't prepare. So these definitions for the IP examinations. So once again, so no need to prepare these definitions for the IP examinations. No need to prepare the definitions. They will ask the one definition. Starting definitions, but not in these definitions. So now, what is the meaning of periodic matrix? The square matrix. The square matrix capital A is said to be periodic matrix. Periodic matrix A. And there exists a positive integer n, so that a power n plus 1 equal to a. A power n plus 1 equal to a. Here, the least positive value of n, so that a power n plus 1 equal to a is called the period of matrix. The period of the matrix. Now, next slide, orthogonal matrix. Orthogonal matrix. The square matrix capital A is said to be orthogonal matrix. If A into A power T into A is equal to I, where I is unit matrix. So therefore, A is orthogonal. Example, A is equal to is orthogonal. Already we have seen in the exercise, we have a question in the exercise. See, prove that A is equal to cos alpha sin alpha, isn't it? Cos alpha sin alpha minus sin alpha cos alpha. Then prove that A into A transpose is equal to here minus 1, here minus 1. Cos alpha sin alpha sin minus sin alpha cos alpha. Then so see the previous problem, maybe it's problem number 4 in second Roman. Second bit first one. So already we have seen in exercise 3C, second Roman first one. So write it. First write down the periodic matrix. After that, orthogonal matrix. Next one is unitary matrix. Next one is the unitary matrix. Unitary matrix. The square matrix. Capital A is said to be unitary matrix. If A into A power theta equal to A power theta into A equal to I, like a orthogonal matrix. In place of P, we have here theta. So what is the meaning of A power theta? Transpose conjugate of a matrix. No? Transpose conjugate of a matrix. We have seen already in the previous class. So therefore, A into A power theta equal to A power theta into A equal to I. The last side heading, polynomial of a matrix. So last side heading is the last side heading in the entrance examination point of view. So polynomial of a matrix. If A is the given matrix, given square matrix, and f of x is equal to a0 into x power n, a1 into x power n minus 1, a2 into x power n minus 2, so on. A n minus 1 into x plus a is the given polynomial. Given polynomial of degree n, where a0 comma a1 so on a are constants, are real or complex numbers. Then real or complex numbers. I will give the example for it. Then f of a equal to a naught into a power n. A power n minus 1. A to cap A power n minus 1. So on. A n minus 1 into a n into I is called the polynomial of a matrix. Polynomial of a matrix. This polynomial contains matrices where I is unit matrix. I is unit matrix. Same ordering of order same as n. A. Same as means order of I equal to order of A. Now see the example. So this polynomial is created by put this one. Put x is equal to a now. So this polynomial is created by substituting x is equal to a. X power n means a power n minus 1, a power n minus 2 like that. But here we have some variation. Example. If f of x is equal to x square minus 3x plus 2 and A is the square matrix, then f of A is equal to a square minus 3a plus 2i. Just we are putting x is equal to this one. Or it can also be written as f of x is equal to x square minus 3x plus 2. Can also be written as x minus 2 into x minus 1 now, by taking the factorization. So now from here f of a is equal to how much? A minus 2i into a minus I. It is 1i and it is 2i. Since we cannot add the matrix and see this one. 1, 2, 3, 4 plus 2. It is not possible. You cannot add matrix and number. You can add the two matrices or two numbers. Similar point should be added now. Either two matrices or two numbers. So that's why you are writing here 2i. Here I should be 1, 0, 0, 1. Then you can add the two matrices. Why you are saying order of I and order of A should be same? When you are adding the two matrices, their order must be same. That's why you are saying the same order. In the addition, we need a same order for the two matrices. So that's why you are saying same order. So write. By factorization method it will be obtained. So from here definition will be ended here. Definitions are over in the examination point of view. Entrance examination point of view, the definitions are over. Now you are entering into IP syllabus. Up to here. So up to here the definitions will be ended for the entrance examination point of view. So now we are entering into the intermediate examination syllabus. So determinant of a 2x2 matrix. So the next definition is determinant of 2x2 matrix. ఇబ్బంది పడకండి ఎంట్రన్స్ ఎగ్జామినేషన్ పాయింట్ ఆఫ్ ఇక్కడ వరకైనా ఇప్పుడు మనం ఐపీ సిలబస్కి డిస్కస్ చేస్తున్నాం ప్రిపేర్ చేయాలి అక్కడ నోట్ చేసి పెట్టుకోండి డెఫినేషన్స్ ఆర్ ఎండెడ్ ఫర్ ద ఎంట్రన్స్ ఎగ్జామినేషన్స్ అని రాసుకున్నాను తర్వాత గుర్తుండదు మనకి సో గివ్ ద అండర్లైన్ now next heading determinant of 2x2 matrix. So if capital A is equal to A, B, C, D is the given matrix, then the value A, of course, see this AD minus BC is called the value AD minus BC. How we are creating? There is some logic now. AD minus BC is called the determinant of the matrix A. So it is denoted by det A or determinant of A or determinant of A, B, C, D. All are similar. Det A, determinant of A or A, B, C. So therefore, det A is equal to A, B, C, D. This implies. So det A is equal to, you can take the cross multiplication here. AD minus BC. Example. If A is equal to 1, 2, 3, 4, find det A. So write one example. Solution. 2, 3, 4. So det A is equal to determinant of, now see the symbol. It is the matrix and it is the determinant. Now see the symbols, or you can compare the notation. When you are writing the square bracket, it will be matrix. Just you are putting the lines now, it will be determinant. So notation will be there. Now multiply this term. Formula is there, no? AD minus BC is equal to formula. Sorry, AD BC is equal to formula. AD minus BC, no? ABCD. The formula is like this. Now by using this concept, 1 into 4 minus 3 into 2. So answer is 4 minus 6 minus 2 is det A. Right. Example 2. If A is equal to 6, 8, 4, 3, then find det A. Solution. So A is equal to 6, 8, 4, 3. Then det A is equal to how much? Determinant of 6, 8, 4, 3. Now see the concept. 6 into 3, 4 into 8. 18 minus 32. So now you can write the answer. Minus 14, no? So one more example. If I is equal to 1, 0, 0, then find det I. So determinant of I is 1. So det I is equal to 1, 0, 0. When you are seeing the formula, 1 into 1 minus 0 into 0. Answer is 1. So now we can observe the one thing here. So what is that? Determinant of unit matrix is always 1. Determinant of unit matrix is always 1. For any order number. For any order in the sense of, it is 2 cross 2 matrix, no? 2 rows and 2 columns are there. Determinant is. So if I take like this, 1, 0, 0, 0, 1, 0, 0, 0, 1. So its determinant is also 1. So give the one statement. Determinant of identity matrix is always 1 for any order. So make a note. Determinant of identity matrix, that is I, is always 1 for any order. It is applicable for any order. So make a note now. Determinant of I is always 1. So write down. First write the definition of then 3 examples. After that make a note. Determinant of identity matrix I is always 1. So it is applicable for any order. Any order in the sense, use the square matrix only. So next item is minor of an element. Capital M. Minor of an element. Minor of an element. Minor of an element. If capital A is equal to, capital A is equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. A2, B2, C2, A3, B3, C3. Then the minor of an element in this matrix is denoted by defined as the determinant of of 2 cross 2 matrix. So observe, given matrix is of order 3 by 3, but we are discussing about 2 cross 2 matrix. So how it will be obtained? Obtained after deleting the row. After deleting the row and column, deleting the row and column in which the element present, So don't confuse the sentence formation. So I will give the example, or you can write down alternate definition for it now. I will give the alternate definition for it. If capital A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33 is the given square matrix of order 2 3 by 3, no? Then the minor of an element, you can take general element Aij is the determinant of 2 cross 2 matrix. Determinant of 2 cross 2 matrix obtained by deleting the ith row and jth column. So it is denoted by Of course, the minor of an element Aij is denoted by capital MI. So don't confuse here Aij. So what is the meaning of Aij? Ith row, jth column. The element at the position of ith row and jth column. Give the example. See this one. If I take A12, what is the meaning of this one? First number shows row, second number shows column. Already we have seen the meaning of A12. So once again, what is the meaning of A12? First row, second column. What is the meaning of A13? First row, third column. So like that. So the meaning of Aij is ith row and jth column. So see the example. See the example. I am giving the example. If capital A is equal to A11, A12, A13, A21, so A23, A31, A32, A33. Then, so I am writing the minus of each and every element. How we are writing? So see this one. Minor of element. We have seen first this one element A11 is equal to M1. So this is equal. Here we have element now. So he is saying delete that row and column. అంటే అర్థం ఏంటి సార్ అంటే ఆ ఎలిమెంట్ ఎక్కడైతే ప్రెజెంట్ అయిందో ఆ రో ను కాలమ్ డిలీట్ చేస్తున్నాడు. హియర్ వి హావ్ ఎలిమెంట్. డిలీట్ దట్ రో అండ్ కాలమ్ కంటైనింగ్ ద ఎలిమెంట్. ఆ ఎలిమెంట్ ఎక్కడ ఉందో ఆ రోని కాలమ్ ని డిలీట్ చేయండి. తీసేస్తే మిగిలింది ఇదే కదా. వి హావ్ a 2 by 2 matrix. We have a 2 by 2 matrix. After deleting this row and column, we have a 2 by 2 matrix. So that determinant will be minor. This is one. A22, A23, A32, A33. So don't confuse here. We are writing determinant sign. A32. So answer is wrong. So this is equal to A22, A33 minus A32, A23. So I will give the one more example. Next one we are writing. Minor of element. Next element is what? A12 is denoted by M1. Don't confuse. 12 is same. Small a means element, capital M is minor. M for minor. So see this one. Here we have element. Here we have a element. So don't confuse here. Once again, so I am writing the notation. A11, A12, A13, A21, A22, A23, A31, A32, A33. So we are writing the minor of this element. Minor of this element. So delete the row and column. ఆ ఎలిమెంట్ ఎక్కడ ఉందో రోని కాలం రెండు డిలీట్ చేయండి. ఇక్కడ ఉంది కదా, ఈ కాలం డిలీట్ చేయండి, ఈ రో డిలీట్ చేయండి. ఎలిమెంట్ ఎక్కడ ఉందో అది రోని కాలం డిలీట్ చేయండి. డిలీట్ చేసినట్టు మిగిలింది నాకు. సో దిస్ ఇస్ ఈక్వల్ టు డిటర్మినెంట్ ఆఫ్ రిమైనింగ్ ఎలిమెంట్స్ ఆర్ A21, A23. Remaining here A31, A33. This determinant will be minor for the element A12. So prepare a determinant. Determinant, why you are writing a determinant symbol? It is of the form ABCD. So already we have seen the definition of determinant of 2 by 2 matrix. AD minus BC is there, no? So like that. So see this one by cross multiplication it is A33. So answer is A21, A33 minus A31, A23. So right. A element కావాలో దాన్ని డిలీట్ చేయాలి, రోను కాదు. So right from here now. So start the definition here. We have alternate definitions. A1. So we are deleting this one. So remaining here effect. Next one is third element, A13. Minor of A13 is M13. So here we have an element, no? So delete this row and column. A21, A22, A31, A32, isn't it? Here we have an element. So delete this row and column. A21, A22, A31, A32. So determinant is A21, A32 minus A31, A2. How many minors are possible? For each element there is a minor, no? So we have a 9 elements. Means 9 minors are there for the 9 elements. Next one, minor of A21 is M21. M21 means this one. So delete this row and column. A12, A12, A13. Next one is A32, A33. You can explain. Next, minor of A22 denoted by M22. Next, minor of A23 denoted by M23. Six elements are over. Next, third row, minor of A31. Next, minor of A32. Now last one. Now M22 means here we have a A22. So A11, A13. Next A31, A33. Next 2, 3. A11, A12. Here A23. Delete this column and row. A31, A32. No? Next M31, A12, A13, A22, A23. Next middle element A11. For this element we are writing. So this is delete this row and column. A13. Here we have a notation. A21, A23. No? Next last one is A11, A12, A21, A2. Now you can expand a little bit for each and everything. Okay? You can expand a little bit. A1 to A33 minus A3 to A13. Next heading is cofactor of an element. Next heading is cofactor of an element. Cofactor of an element. Nana minor ఉండేది ఎలిమెంట్ కే కోఫాక్టర్ కూడా ఎలిమెంట్ కే రాస్తున్నాను బట్ ఎలిమెంట్స్ ఆర్ ఇన్ matrices. Now the cofactor of element, if capital A is equal to Aij of order 3 by 3, it can also be written as A11, A12, A13, A21, both are same number, A22, A23, A31, A32, A33 is the given matrix. Is the given matrix of order 3 plus 3. Then the cofactor of an element Aij is denoted by capital Aij and defined as minus 1 whole power I plus j into mij, where mij is minor of element A, minor of element Aij. So therefore, so see this one. Cofactor of small aij is equal to aij. So this is equal to formula minus 1 whole power I plus j into mij. Minus 1 whole power I plus j into mij. Where mij is already taken as mij is minor of aij. Aij means element. Now we can give the example. So just I am writing the cofactors of each element. Example. If capital A is equal to A11, A12, A3, A21, A22, A23, A31, A32, A33. Then number 1, the cofactor of A11 is equal to, now we are putting I1 and J1, this one, capital A1. Now write I1, J1, don't confuse here. Write I1, J1, then it will be A11. See the element here, A11 means put I equal to 1 and J equal to 1. Now I equal to J equal to 1 right now. So now here A11 comes, what about this one? Minus 1 whole power 1 plus 1 no? Into M11. But you can write minus 1 whole square it is. Minus 1 whole square becomes plus M11. So what is the meaning of M11? Minor. Already we have a M11 value in the minors. So this one only now we are writing the minus of this one. So determinant of So when you are writing the minus, you have to delete the row and the column at the element present. Here we have element. So delete the row and column A22, A23, A32, A33. So now we can expand it. So this is equal to. So this is equal to. We have a plus before it. A22. So this is equal to A22, A23, sorry, A33 minus A32, A23. It will be positive of something. Now, next one, cofactor of this element A12 is noted by capital A12. Means what? First suffix is I, second suffix is J. First suffix is I rayali, second suffix J rayali. Enduku rayali sir? We have A I J. First suffix is I, second suffix is J. So first suffix I means what? 1, J value 2. Right? I1 and J2 here. And first suffix lo 1 undi, second suffix lo 2 undi. And I1 rayali, J2 rayali. Right? Main formula minus 1 whole power 1 plus 2 into M12 now. So minus 1 whole cube comes. 1 plus 2, 3 9. Minus 1 whole cube is negative. Minus M11. Sorry, M12. So this is equal to minus of, what is the value of M12? Minor. M12 means minor. Already we have a value, but we can see here also. Here we have element. A12 అంటే దీనికి రాస్తున్నా. దీనికి రాస్తున్నప్పుడు ఈ కాలమ్ ను రో తీసేయండి. So delete this row and column. See this one. We have A21 and A23. A21 and A23. So delete this row and column. A21 and A23. A31. A33. Now it can be expanded. Minus of determinant expansion. A21, A33. Minus A31, A2, etc. You can write remaining 7 cofactors now. And alternate plus and minus comes now. So it will be plus, it will be minus and plus. So like that one. A11, A12, A13. Alternate plus minus constant. So see this one, it is plus, minus, plus. See this one, it is plus and minus here. Like it is. Minus, plus, and plus comes. Here one symbol. Why? odd number and even number in the power. Here 1 plus 2, 1 plus 1, 2 plus 2 like that. Odd power and even power for minus 1. So here cofactor of see this one, cofactor of A13 is capital A13 is minus 1 whole power 1 plus 3 plus into M11 M13 is plus of result is out A11 A12 next one A31 A32. So it is same answer plus of. So here we are writing A13 A21 A22 next A31 A32 enough. So like that you can write remaining 6 cofactors. So you will write the remaining 6 in next class.